So here in example 1, we factored completely, but sometimes, and I don't know if you want to add this as a note, sometimes if you have the same factor, but like the numbers are switched, one is x minus 1, the other one is 1 minus x, you can factor out a negative, and then they're going to actually cancel out. So when we go to list our non-permissible values of this one, right, x can't equal 1, but it'll end up being a whole. And it's going to be a whole at, well, 1 comma something. We can always find the y coordinate of the whole by looking at the new equation. And after I cancel out that negative 1, the x minus 1s, I have x minus 4 left on top. I have a negative 1 left on the bottom. That negative 1 on the bottom, you can simplify this side of the equation because x divided by negative 1 would just be negative x. And negative 4 divided by negative 1 would be plus 4. So I'm going to put a green box around this because it fits with our green note. It says, if there's a whole, you graph the simplified equation and add the whole. And the whole is going to have the non-permissible value for your x coordinate. And then you plug it into your new equation. So if I plug in 1 for x, negative 1 plus 4 is 3. That's going to be the coordinates of the whole. At this point, you graph the green equation. Okay? Number one mistake in this unit is students see that the degree is bigger on the top here than the bottom and think they need to find an oblique asymptote. But because it's simplified, your new equation is just a line. Lines do not have asymptotes at all. So we just go graph our line. Right? How do we graph negative x plus 4? We'd have a y-intercept at 0, 4. A slope of negative 1, down 1, over 1, down 1, over 1. But 1, 3 is a whole. We draw that with an open circle and add arrowheads to our graph. All right, you can circle question number 3 for practice.